Yay for short people. So hello everyone, good afternoon. It's great to see you guys, probably everybody for the last time, right? I'll be there for graduation, I have to. Welcome to those of you joining us live stream. This is going to be the most epic presentation ever of the last 2 years. Okay, so let me introduce you to Charles Bean. He joined us as a junior at LSMSA, so I only got to be with him for actually just a year, if that, right? So I saw him first in my C++ class, and I was like, this kid's got potential. And so I was like, okay, let's see where he goes with this, right? So a few months down the road, I think it might have been maybe a few weeks even, we were on a bus ride, a long bus ride to a college fair in Baton Rouge. And the bus was very full. There was only one seat left, and it was next to poor Charles Bean, okay, for me. So I was like, poor kid, he has to sit next to a teacher for 3 hours. But anyway, we sat down and we started chatting. And of course, we started talking about computer science, and then that eventually led to, where do we want to go to college? Right? So that's like my favorite question to ask. So, and we ended up talking for 3 hours almost, not knowing where the time went. And then that's how I got to know him. And then another month went by, and he said, hey, how about a distinction project? I was like, okay, what you got, you know? So he said he laid out this plan, which I'm going to let him explain to you. Something about automation and like doing attendance using an automation system, doing textbook check-in, check-out, using all of that. So it's like, okay, what's in this for me? So he's like, I can build you a house by the beach when I'm rich and famous. And I was like, good, you're done. No, that was all lies, guys. We didn't have any of that arrangement. Okay, I just made that up. So yeah, we sat down and we were like, okay, let's do this, like, you know, pretend to be software engineers. So we sat down and we just kind of came up with this diagram. It wasn't even a flow chart. It was this rough diagram. We were both software architects for the next few hours. We came up with this plan. And soon after that, we had to go home for COVID, right? And Charles had all these things on his project laid out. We submitted the proposal and it was approved and everything. But this project involved not just software, it also involved hardware. And guess who was struggling with COVID first? China, right? And all our parts were coming from China. So we had to make so many adjustments because there weren't any parts coming in, so we changed our plans from using an Arduino to a Raspberry Pi, and then back to Arduino-ish kind of system, which he'll explain to you. It's called a Node MCU. Eventually, the software design was the same, but Charles was just amazing in being resourceful and then figuring out, flexible, figuring out how to make this thing work with what we had. So he did it. I don't know how he did it. With everything being shut down, he came up with this design and the project pretty much on his own because I was here, he was over there, and it was just crazy. Whatever though. At the end of this project, I would suggest you guys do 2 things. You know, shake his hand, well, not like that, but however you shake hands, get to know him. If you don't, get his number, okay? Because he's going to be freaking famous and successful few years down the road, and you might want to know him. So have that in mind, and also have your phones turned off or silenced. That's it. Okay. So Charles Bean, everyone.
Hello. I hope you are all doing well. So this is campus automation using tall people problems. So this is campus automation using RFID technology. So first, in order to understand this project, I have to give you a basic description. There's 3 parts. there's RFID tags, which are right there. The RFID box on the top right, and a MySQL database, which I'll get into later. Basically, the concept is that whenever students scan their tags on the RFID box, it sends that tag scan to the MySQL database, which is like an Excel spreadsheet, which can then be used to figure out that the student was at that location at that time. So why do we want this? Well, here at LSMSA, students have to declare what they are numerous times throughout the day. Whether that be whenever they're in class and the teacher calls attendance, whenever they're on the reach out that we all know and love, and we have to say that we're going to the HSB or the CPT, whenever we have to speak up in the dorms, whenever we're at community meetings or a meeting like this and they have us sign a sheet, or whenever Prim's making chips and salsa and Prud'em and we all have to sign the attendance sheet to show that we're there and get more chips and salsa the next week, right? A lot of these things either take too much time or aren't COVID friendly. For example, where we have to sign our names, we're all using the same pen. That's not sanitary, right? And classroom attendance takes way too much time. We're going to start at the second bullet point, right? So according to the master schedule, there's 262 classes. Each of them meet about 2.5 times a week for 32 weeks in a school year. That means that classes take attendance 20,000 times, right? If we assume that it takes 1 minute per attendance, this is 350 hours or 14.5 days per school year that teachers are taking attendance instead of teaching their classes, right? Also, the current solutions to sign in, sign out on Reach are buggy and not dependable. I know a lot of my friends don't update it. We just say we're going to the CPT in the morning, we come back to Prud'em at the night. So, what is RFID technology, right? I have a little flow chart here. As you can see in the top right, that is the inside of one of the RFID tags. There's a coil of wire and a little microchip that has data on it. So there's a RFID reader, which I'll get into later, that broadcasts radio waves. Whenever the RFID tag comes by the RFID reader, it gets powered by these radio waves, very similarly to how we wirelessly charge our phones, right? It then sends its data back to the RFID reader, and then it repeats. What are some examples of RFID technology, right? We use it to get into the buildings with our IDs. Apple Pay, whenever we're checking out, right? And the bottom left, that's a clothing tag at a convenience store or a clothing store. So whenever you're walking out, they have those big side rails. Those are actually RFID scanners, scanning for those RFID tags on your clothes, right? AirPods, whenever you hold them close to your phone, that's RFID that recognizes them. And fast lanes, whenever you're driving through, there's an RFID tag in your car that it scans so that it can automatically charge you. So, the RFID tags we're using, students would carry on their lanyards, similar to this, right? And it stores a 4-byte hexadecimal ID. That's a base 16 number, right? What this means is that since there's 8 of these numbers that are hexadecimal, there's 4 billion different combinations, right? Now, whenever we buy these, we get them pre-programmed with an ID that's random. But this isn't much of a problem since if there's 4 billion combinations, the chances of 2 of them being the same are none. And each ID is assigned to a student. The RFID box, it's what scans the RFID tag, right? And it's placed outside classrooms or buildings, or like I said, if we're having something like this, it would be placed outside so that whenever you're coming in, you can scan your tag, you're here, right? On the box, there's an LED, right? Now imagine if the Reach app, whenever you declared where your location was, it just closed. And if you opened it again, it wouldn't say where you are. You would have no feedback that it actually put in your location, right? So basically, responding back to the user is important. We do this because whenever it successfully sets up, i.e. whenever you plug it in and it connects to everything, we'll get into that later, it blinks 3 times to let you know. And then whenever you successfully scan your tag, it blinks for 1 second. There's also a power port this is just, you just plug it in. This can be done through the computers that have the USB ports in the CPT classes, or through a wall outlet that's nearby, or even through a power bank if it needs to be somewhere like up here where there's no real chargers. And it's micro-B. Alright, so inside there's two boards. There's a Node MCU at the top and a RC522 at the bottom. Right? Alright, the Node MCU, this is the brains of the thing. It runs the program, and it receives the data from the RC522 that has it's the RFID scanner, right? And it is also what sends the data to the MySQL database. So on here, if you see right there, that's a little Wi-Fi chip, and that's the antenna. And so it actually connects up to the school Wi-Fi. That way it can, send the data wirelessly. The RC522 is what scans the RFID tags and then sends those tag IDs to the Node MCU. And as you can see, I was showing you that coil of wire earlier. There's a very similar one on here. The MySQL database. So this is similar to an Excel spreadsheet. As you can see, there's columns and there's rows, right? And this is what actually stores the RFID logs. Each row is a separate scan, and each column is a different type of data. So as we can see on the left, there's the time. In the middle, there's the actual RFID IDs that the students are scanning in with. And then on the right, there's the location. So this one would be Recital Hall 430. Here's a data flow chart of all the things. As we can see, we start with the RFID tag that is scanned on the RFID box, and it sends its 4-byte hexadecimal ID, right? That RFID box then sends that RFID ID, grabs the time from a public server, and it also says its location and sends that to the MySQL database, right? And then the computer can interact with both of those to download logs or also set up the RFID boxes. Alright, so how do we implement the RFID tags? Right? We would have one of these boxes that just shows the RFID tag ID onto a computer. We would then put this into an Excel spreadsheet right next to the student's name and the student's ID. Right? And then we would give the students their RFID tags in their mailboxes to ensure that they're properly distributed. So if we have a bunch of them, right, you can't really tell the difference between them because they all look exactly the same. But if we put them in the mailboxes, we can make sure that they get to the right student. And then once they go into the IDs, well, they're labeled, so we don't have to worry about it. Alright, here's the program flow chart. It connects to the Wi-Fi, or here, yeah. It connects to the Wi-Fi, it connects to all the servers, sorry, and then it blinks 3 times to confirm that it has everything and that it's set up correctly and it's ready to have RFID tags. It then waits, and it keeps looping around, waiting and waiting and waiting, and then it tags scanned, and it gets the ID, and then grabs the time off the public server. We'll get into that later. It then sends all that to the MySQL server, receives confirmation that it's sent successfully, and then flashes for 1 second. And here, actually, this is a good time for the demonstration because earlier, 1 sec, sorry, right here. It clearly says demonstration, I can't read it. All right. I'm just setting up the network real quick. All right. All right. So it's going to connect, and then it's going to flash 3 times. There we go. And then I'm going to scan the RFID tag. As you can see, it turns on for 1 second. And if we look at the MySQL database, there it is at 444. I can't get this larger, but right there it says 444. There's the RFID ID, and there's the location that it's set to. And we can do that multiple times if we scan again and again. And there should be 2 or 3 in here now. Yeah, there we go. Okay, so this is a program overview. So we start off with loading all the classes, right? And then we set up the RFID reader. So this is actually telling the node MCU which pins to use, and then it declares those pins to the RFID reader, and then it sets up the string that actually holds the ID whenever it reads it. Alright, and then it sets up the Wi-Fi. I took out my Wi-Fi password so that you guys don't use it in the dorms, sorry. But there's the username, the password, and then it also sets that up. And then MySQL. This is where the MySQL IP address goes. MySQL username, the password. This is where the location's coded in. And then it connects to it, and then it sets that basically tells it this is where it's connected to, so you can then call it later. Alright, network time protocol is a publicly owned time server. For example, Google has one, and whenever you ask it what the time is, it responds back with the time. Right? So we start with that, the class, and then this actually is the offset from UTC for Central Standard Time. It's negative 18,000 milliseconds. And then we declare the time client, start it, or create the string that would then hold the time whenever we get it, and both of those are for that. Alright, and then it connects to the Wi-Fi. This is where it gets used the pointer. So it says that it's connecting, and then this is the IP address and the password, or the name of the password, sorry. And then it waits until it's connected. Every half second it tries again to check, to check, to check, and then whenever it's connected, it says it's connected, declares its IP address, and then declares the IP that it's connected to. And then we connect to the MySQL server. So it says that it's connecting, and then it tries to connect, and this returns a true or false statement saying whether or not it's corrected. If it's true, it says okay. If it's not true, it failed, right? And then this declares where we can call the MySQL server. This starts the time client, the time server. Alright, but we have to make sure that it actually connected correctly and notify people so that we actually can use it. Right, and we know that it's going to work. So if the MySQL server is connected, or this is the MySQL server, sorry, and the Wi-Fi is connected, then it blinks 3 times. Each of these highs and off, and then this waits 0.1 seconds, sorry, and then it turns back on. So it's off 1, off 1, off 1, off. Right, we start with off just to make sure, just in case it starts with on, it's all good. Yep. Alright, and then it waits for an RFID tag. This is the loop. Alright, yeah. So if a new tag's present, or if there is no new tag present, sorry, that's what that exclamation mark means, it returns and thus it starts the loop again. Checks for a new tag, no new tag, starts again, right? If it gets past that, then it sees if it can read the card. If it can read the card, we're good. If not, it starts the entire loop again. Alright, so assuming we had a successful read, it then takes the UID, which is basically the 4-byte ID that I was talking about earlier. It takes the first byte, converts it to hexadecimal. Second byte converts it to hexadecimal. Third and fourth byte as well. It starts at 0 because in programming, arrays and stuff start at 0. That transfers here as well. It converts it to uppercase, and then it adds it to an array. Then it grabs the time, sets it to a variable, and then sets it to a variable, basically. That's what those bottom twos do, sorry. It then sends, or it declares this, which is a string. And all this would be one line, but I had to space it up so that it could go onto the slide. And this is, oh, sorry. Did it go to the, sorry. Okay, yeah. So it's inserting into the SQL server. It's called Classrooms prod. There's the time, the RFID ID, and the location. It then has the values of the location that we said earlier. It was hard-coded in. The time that it grabbed from the time server, and the ID, as well as the location again. This location is set to the name of the table. So that first location says, okay, put it into this table, which as we saw earlier, this table's name is class 231, right? And then it also sets a variable in there to T231. We then send it to the SQL server. And once it's sent, we flash for 1 second. So what is the cost to implement this, right? Well, there's three factors. The RFID boxes and the RFID tags, which are one-time costs because they can be handed down year over year. You know, students turn in their RFID tags at the end of the year, and boxes can be reused from place to place. But we're also hosting the MySQL database in AWS, which is Amazon's hosting platform, and that has a yearly cost. So here's the boxes. As we can see, the two circuit boards, the micro USB cable, and then some screws that hold it all together, as well as the 3D printing filament, which comes out to 89 cents. And the total cost of one of these boxes is $8.62. RFID tags are 18 cents a pop, and we need 360 of them for every student here. That comes out to $65. The MySQL hosting is, I'm not going to get into the math, but it's about $50 a year. So the total cost for 360 RFID tags, 50 RFID boxes, and 1 year of MySQL hosting puts us at a first-year cost of $550. But the recurring cost is just the MySQL hosting, which is $50. So after the first year, this is very affordable, especially if you consider that we take attendance 20,000 times. We also have to have people that speed bump us, people that have sheets that we all fill out. And if all of this was automated, we'd save, like I said, 350 hours. That's almost $1 an hour, or way less after the first year. What about privacy? You know, I mean, if we're using RFID tags that can identify us, shouldn't we be worried that whenever we scan them, someone can tap in and say, okay, they're in the CPT right now? Well, thankfully, like I showed you earlier, these only have a 4-byte hexadecimal ID on them that cannot recognize you in any way, unless you look at the Excel spreadsheet that connects the two of them, right? And the only place where you can find this is behind a password. Also, the MySQL database, since it's hosted on AWS, I can have it set up to where it whitelists the school IP, and no external IPs can actually connect to it. Thus, if you're not on the school network, or if you're not on a special Wi-Fi network that would be set up for these RFID boxes, you can't add anything into the MySQL server, can't take anything out, it's as is. So the evolution of the design. This is what we started with. As you can see, there's the RFID reader, literally rubber banded onto a breadboard to hold everything together. And whenever it scans everything, it prints it onto this little display. This is more of a proof of concept than anything else, but it worked. And it actually won 3rd place in the Congressional App Challenge, LAO 6 district. So this is me presenting it to Congressman Garrett Graves and one of the vice presidents of IBM, Charles Masters. But, gotta take it a step further. That was a lot of parts and it wasn't that pretty. So I condensed it down to 2 circuit boards, and this is where most of the actual programming and stuff happened, and it was making sure that it worked with these parts, right? Because you don't want to build a box around something and have everything planned out, including cost and all that, if you don't know if it's going to work. So you have a very bare bones thing, get it set up, and then whenever you get it set up, you can start making a box. Like this one. Doesn't look that good. Has very sharp corners. It's way too thick, uses too much material. The port looks horrible. Not a very good box. But this is where we are now. Smooth corners, nice little pegs to put the things there in place, you know, the LED hole, screws, it's great. Alright, but where can this go? One of the things that I'd like to implement in the future is a backup database. If you remember the program flowchart earlier, if it doesn't get a good MySQL connection, it just says no-go, and the box doesn't work right. But what I'd love to have happen is that if it scans an RFID tag and there's an error, it sends it to a backup MySQL database. This would make it redundant, make sure that it works all the time. Also, we could have backup boxes. Well, if classroom attendance is based on this, what if a box breaks, right? We would have a second box come in that would be in like a main area or something. And then there would be a master RFID tag that has a variable on it that would say, okay, this is class T231, and each class would have their own tag that would say the location. So they would grab the replacement box, It would start up like normal, connecting to the Wi-Fi, blinking 3 times, but then it would wait for the teller tag. That's the tag that says where it is. Whenever it gets that tag, it would then set that as its new location, right? And then it would start to wait for the RFID tag. That way, if things break, there's a backup, everything works smoothly. Attendance correction, right? If we're going to base this off of a non-human element, there needs to be a way to correct it. So I'm going to take you through this. So, set time hits after classes, let's just say 8 o'clock at night. It sends attendance to every student via email. So it says, okay, this is your attendance, you were here for all these classes, but you weren't here for this one. It also provides you with the Google form. If the kid doesn't fill out the Google form, attendance is good, everything works as usual. But if he does, or she does, it notifies the teacher, and then the teacher has the option to approve the correction or ignore the request. If they approve the correction or ignore the request, the attendance is automatically updated. But if they reject the correction, it stays as it is. Challenges with COVID-19. So this is a project that we implement at school, which means we have to be at school. And we weren't at that for most of this time, so it was really hard to get things working out, testing them, and things like that. There's also supply chain shortages with getting the parts made. I've had to change the design multiple times, as Sanjita was pointing out. And in the end, I wasn't even able to get it from China. I had to order it from Amazon at markup prices. It's also hard to organize the testing without being on campus. I don't know if you guys noticed this, but this is not tested yet. It's a proof of concept, but we don't actually have it in classes. We're hoping to in the future, though. I'm going to get into that in a second. Looking forward, this is the second. Testing in select classrooms. We're hoping to get a couple of these in a couple of classrooms in the CPT and handing out RFID tags to students in those classes, and then whenever they come in, they can scan, and we can see if everything works. During this time, we're also going to be bug fixing. Also, if things work perfectly, possible integration at LSMSA. That'd be nice. There's also documentation that's going to be coming because right now I'm the one that knows how to operate this, but that's not a good product. There needs to be documentation on how to do everything, how to set things up, what if something goes wrong. There needs to be a second for that. If I had more time and money, I would get an injection molded case for these boxes. Currently they're 3D printed. It works, but they take about 6 hours each to print. It's way too long. It also each of them has to be done. There's like 10 minutes of time to pull support out and stuff like that to make sure that it all looks nice and pretty. Also, RFID box wall holders. That way, if you're walking into a place and you have your ID, you don't want to have to reach all the way down to scan it. So if it's on the wall right next to you, you can just scan it right there, and you're good. So MySQL has a backend, which is basically where code can tell it to put in a piece of attendance, and this is called Blackbaud. I'm currently working on Blackbaud integration, and we're going to see how that goes. And possibly full LSMSA integration. It'd be great if that happened. All right. Is there any questions or suggestions? I'm open to ideas.
Do you consider fingerprints? Code right now, that one is.
I did consider fingerprints. I also considered barcodes, but the problem is that these scanners cost too much. So to try to keep the price down. Also, the teller IDs, like I was talking about, is kind of hard whenever there's a fingerprint because you can't have a fingerprint say, hey, this is class T231, or hey, this is the recital hall. But yes. Yeah?
So just to confirm I understand, the wall-mounted boxes would be something similar to what we have locking doors already? Like it would be that sort of system?
Exactly, it would be that sort of a system. I was trying to get the IDs in our IDs, I guess, to work with this system, but unfortunately, I couldn't figure out how to get a read on it. So it's probably encrypted in some way. So that's why we have the backup RFID tags as well. But yeah, it is very similar to the door system, and it would be like a second step almost. What's up?
And I guess sort of a follow-up, if you could, if you were able to, like with more administrative help or something like that, would you ideally want to code the system to work with our IDs rather than a separate chip?
I would love to. That's a great idea. Another idea that we had, if we can't have it work with our IDs, which is the perfect outcome because we don't have to worry about sending it out to students or anything, we're already buying IDs, is you can basically put a sticker of the RFID and it just has the coil and the microchip as I showed you earlier on there. That way there's no separate tag. But like I was saying with supply chain restrictions and stuff like that, currently the tags is all that we were able to get. Yep.
What about user interface? It seemed like it's not that making box you either have to directly edit it or use it. Teller ID, which itself will probably also require an improved directly as well. Is there any sort of user interface that can make that easy?
Yeah, so currently you're right, we do have this system, which is not the best system to view everything. Hopefully with the teller IDs, they'd be all pre-programmed so that teachers don't have to program it and then scan it on the box. They'd be just like hanging on like a commando strip or something. But this is currently the best method. I'm hoping to get a phone app, maybe, where you can just type the location, because all our phones have RFID readers in them, and also you can set an RFID chip with them. And then you just scan the RFID chip, say, we are in the recital hall, and then it adds a table to the MySQL server and also sets that teller key, which you can then scan to make it all work. So not yet, but hopefully in the future.
Follow-up question.
Yep,
So I'm guessing the teller key is just a way of reprogramming boxes?
exactly. That way teachers don't have to pull up the program on their computer, and if there's something that has to start at, say, 4:30 like this, then it can be quickly done. Yep.
I have a suggestion for you.
Heck yeah.
I'm really impressed with your presentation. Make sure you're moving forward, if you're developing stuff, if you're presenting it to the school and IBM, look into the intellectual copyright of your ideas.
I'm looking into that. I don't know much about it, but I'm trying to figure out more. But thank you. Yep.
Is the system optimized? Well, you did mention how it can be used for CISO and attendance.
Yes. So for CISO, it could be placed outside of like the CPT doors, and then whenever you would come in, you would scan it on the RFID box, and it would say, "I'm in the CPT now." The downside for that is that you'd have to actually be at the CPT, and they wouldn't know if you're just walking there. They wouldn't know that you're going to the CPT. But it is more of a verification once you're there.
I got a quick question.
Yep.
So in terms of Northwestern properties, like the coffee shop and the library, would it matter if it's on their Wi-Fi or on their internet access? I know nothing about it, so maybe that's a silly question.
No, that's a good thing. So we can actually set it up to work with any Wi-Fi, and then we could go into AWS and whitelist that Wi-Fi network as well, so that it would work in those Wi-Fi networks. So yes, it would work. And we'd have to contact them to set up boxes there if we wanted it there as well. Yep. That's a great question. It wouldn't work if there's a power outage because the Wi-Fi would be down and also the boxes wouldn't be powered, so we'd probably have to go back to what we normally do in a power outage, which I believe is pen and paper. Because I know that the mindless MSA and putting attendance also doesn't work during a power outage. But we'd probably have to go back. This doesn't work during a power outage, yeah. If we had power banks and we used the hotspots that they're giving out to kids currently, I guess we could set up a system that would work during a power outage. Maybe. I'll look into that. That's a good thing to look into. Yep. All right. I would like to thank you all for coming. Yeah. If you guys have any questions or suggestions down the road, shoot me a call or text or anything like that.